In this section, we're going to look at exponential functions. So we are going to look at functions that look like a to the power of x. So now the x value is no longer going to be right next to the a, it's now going to be the exponent. So notice that this is very different than saying f of x equals x squared. This is not an exponential function. However, I can have 2 to the power of x. That is an exponential function. So this is not, this one is. Here, the value of a can only be positive, and you can easily see why it has to be positive. Easily, you can just say, well, let's say it's -2, but then when we raise it to the power of 1/2, remember that to the power of the 1/2, it's just a square root, and we cannot take the square root of a negative number unless we want to go to the complex numbers, and here we don't want anything complex. So, what we're really going to be looking for in this exponential functions realm before we start solving equations and seeing where exactly this occurs, the first thing that we want to see is what exactly does it look like. So what does the exponential look like? So if I were to graph it, what does the graph look like? Well, let's first start off with f of x equals 2 to the x. And this is going to be the case where the value of a is greater than 1. And you'll see why we're taking this case. So the first thing that we want to do, we want to try to graph this thing. And we're going to go straight up x, y. So let's first start off with some general values. So let's say if I plug in 0. If I plug in 0, well, you're going to get 2 to the 0, and anything to the 0 power is just 1, okay? Then what happens when I plug in 1? Well, when I plug in 1, it's going to be 2 to the first power. That's just going to give me 2. What about if I get 2? Well, 2 to the squared is just going to give me 4. 3, 2 to the third power, now it's going to give me 8. Now, we should probably put some negative numbers in here. So what happens if I put in -1? Well, 2 to the -1 is just going to give me 1/2. Okay, and then -2. Well, 2 to the -2 is going to give me 1/2 squared, which gives me 1/4, and so on and so forth. And you can continue with this if you want. And notice here, notice here that these numbers are never negative. No matter what negative number I put it's always going to be a smaller and smaller quantity. Okay, so let's plot them. So at first, you're going to get 0, x equals 0, y equals 1. So 0, 1 is going to be here. Okay. Then 1, 2. Okay, so 1, 2 is there. Then 3, 8. Or 2, 4 first. 2, and then 4. And then 3, 8. 4, 5, 6, 7, 8. Okay, so way up here. And then the other ones, you're going to have -1, 1/2, -2, 1/4. Okay, I'm going to try my best to do these ones. -3, 1/8, that's even closer to 0. So notice that what's going on is that you have the kind of like this exponentially growing thing. Okay, so this one, as x gets really, really big, you start going off to infinity really, really quick. And then as x get really, really, really small, this starts to level off, level off, level off. Okay, so basically what happens here, this is first what we call exponential growth. Okay, so I'm exponentially increasing. And now, in addition, what's going on is that this is getting closer and closer to 0, but it's never going to touch it. So what we're going to do, we're going to write this little imaginary line that kind of denotes that I'm getting closer to this line, but I'm never going to touch it. And this line is what we're going to call the asymptote. Okay, and it's a horizontal asymptote. So let's give it a couple of features. So let's take a look at exactly what is going on. So some of the properties of these exponential growth function. So when you have a function that looks like this, a to the x, and a happens to be greater than 1, these are some of the properties that you have. You don't have to memorize them, but it's useful to know. First, let's talk about the domain. And the domain, if you see, this is going to be from negative infinity to positive infinity. So basically what that means is that you can plug in any x value that you want in here. You're always going to get something out. Okay. The range here, if you look at all the possible y values that I can get, the lowest y value that it seems that it is nothing negative. It starts at 0. And 0 here is not included because that's where the asymptote is at. So it's from 0 all the way to infinity. Okay. If we look at the x-intercepts, does it cross the x-axis at any point? Never does, because you have an asymptote. So you have none. Do you have any y-intercepts? Well, yeah, you have one y-intercept. The y-intercept is at 0, 1. Okay, so you have a y-intercept at 0, 1. The asymptote that you just collected or you just found, this asymptote is at y equals 0. So at y equals 0, you have this asymptote. The shape of this particular graph is increasing because, as you can tell, it's exponentially increasing. Okay. Now I want you to look at 2 points because this particular graph contains 2 different points. Look at the base. The base is 2. When x was 1, you actually got the base back, 2. When x was negative 1, what did I get? I got 1/2, which was 1 over the base. So basically, this contains the point 1, comma a and negative 1, comma 1a. Okay, so that's the point that contains. Okay, and that's basically one of the things that it has. So if you have all of these different features, then you'll be able to figure out what exactly the graph looks like. Okay, now let's look at another example. So let's say we have what if a is between 0 and 1? So kind of like a fraction. So kind of like this, f of x equals 1 over 2 to the power of x. Okay, so 1/2 is the number between 0 and 1. So what would this look like? Well, let's do the same thing. So I'm going to try to graph this. I'm going to plug in values for x to try to figure out what y is. So let's first plug in 0. That's just going to give me 1/2 to the 0 power, which gives me 1. I'm going to plug in 1. This is going to give me 1/2. Let me plug in 2. 1/2 squared, that's going to give me 1/4. Let me plug in 3. 1/2 to the 3rd power, that's just going to give me 1 over 8. Okay, now let's plug in some negative numbers. Okay, so when I plug in negative 1, I'm going to have 1/2 to the negative 1. That's just going to give me, well, this negative is just going to flip it, so it's just going to be 2 to the 1st power, which is just 2. If I have negative 2, that's going to be 1/2 to the negative 2 power. It'll flip the fraction, so it's 2 squared, which gives me 4. Negative 3, same exact thing. So you're going to have 2 cubed, which gives me 8. All right, so now let's go ahead and try to graph this. So first 0, 1. Okay. Then 1, 1/2. Okay, so 1/2 is around here. Then 2, 1/4. Well, 1/4 is even smaller. 3, 1/8. That's even smaller than that. Okay, but it's not quite 0. Then let's go to the negative sides. At negative 1, you have 2. Okay, that's 1/2. Negative 1, I have 2. At negative 2, I have 4. At negative 3, I had 8. 4, 5, 6, 7, 8. Okay, so now if you look at this graph, it looks very different than the previous one. Okay, if I can draw correctly. Okay, so we're in the previous one, you had something that was growing. In this case, you have something that's decaying. So this is what we're going to call exponential decay. So whenever you have something that is between 0 and 1, you're going to have exponential decay. Whenever you have a being greater than 1, you're going to get exponential growth, like here. Okay, so these are basically what the shapes look like. So let's look at some of the properties. Okay, so properties. Okay, for f of x equals a to the x when a is between 0 and 1. Well, some of the things, let's look at them. So domain, the domain change? Domain didn't change at all. It's just still from negative infinity to positive infinity. Now what about the range? My range, in this case, is going to be from 0 to infinity. Still same thing, because it starts, still you have this asymptote, because my x's are never going to get really closer. It just turns out that when x gets bigger and bigger and bigger, my y value gets smaller. So, but you still have the same y values from 0 all the way to infinity. Do I have any x-intercepts? Same thing, none. Do I have any y-intercepts? Yes, I do. Still at 0, 1. So that hasn't changed. So if you see, everything is the same from the very beginning as exponential growth. What about my asymptote? I also have the same asymptote. So my asymptote is still at y equals 0. Not asymptotes, asymptote. Still at y equals 0. So you still have this imaginary line that this is never going to touch. Okay. My shape is now decreasing. So it's no longer increasing anymore. It's now decreasing. And this is going to contain, what are some of the key points? Well, when I plugged in 1, I got the base back. I got 1/2. When I plugged in 1, I got 1/2. And when I plugged in -1, I got the opposite. So when I plug in 1, I get a back. When I plug in -1, I get 1 over a. Okay? So notice that everything is the same. So if you look at here, the properties for these things are exactly the same as this one. The only thing that's different is just that for this one, you are increasing, and for this one, you are decreasing. That is basically the only thing that's different. Okay? So in the next video, what we're gonna work on, we're gonna graph these two functions. We're gonna graph f of x equals 5 to the power of x, and we're gonna look at f of x equals 1/3 to the power of x. Okay, and then we'll do a couple more complicated graphs. Okay.